Hi, I'm Jim Richter, and I'm part of the team that has totally redesigned what is probably the most boring product in your piping system, the cast iron Y strainer. When it comes to piping systems, boilers, chillers, pumps get all the attention. They're the big bucks and the big energy users. Engineers take great care to specify the most energy efficient equipment they can. But when it comes to the Y strainer, they don't even give it a second thought. It's not even on their radar screen. Yet I can't think of any other single piece of equipment working the way it's supposed to that can do more to screw up their energy calcs than a slowly clogging Y strainer. Here's the strainer that we've all grown to accept and ignore. And out of curiosity, I went looking for the earliest drawing I could find, and it was dated 1908, and this one looks identical to that drawing. All that's changed over time is it's gotten smaller, and this was done to make it cheaper. But the hidden costs are more restricted flow and degraded performance. Of course, some pressure drop is inevitable. We're disrupting flow and accumulating dirt. It begins with a restriction of flow into the screen by the bridge wall. This is where the inlet end of the screen seats into the body and the flow direction is changed by about 45 degrees. The restricted flow and increase in turbulence creates a large pressure drop through the strainer. Additionally, as we will see, the screen itself is rather small, which means that on top of providing less room for flow, it clogs quickly. Although this has been the standard for over a century, it's just not good enough anymore. I'm excited to introduce the low pressure drop Y strainer. So different, it doesn't even look like a Y strainer. By eliminating the restriction of the bridge wall, inserting the screen into the strainer at roughly a 25-degree angle instead of the 45-degree angle, and dramatically increasing the size of the screen, we've solved a number of problems. And we've kept the same face-to-face dimension. Available on our website and in front of you now, this CFD animation illustrates the flow through the old Y strainer and our LPD strainer. You can see the remarkable difference in both velocity and direction of flow. If any of you were going to design a Y strainer today, this is what you would design. This is our 4-inch LPD Y strainer, and you can see how much larger our screen is than our competitor's 4-inch screen. With a larger surface area, more water can flow through the screen, and it takes far more debris to block it up. Our product can accumulate a handful of dirt before it even begins to affect flow. And we don't even include this debris pocket in our calculations. Another improvement we've made on the older model is a blowdown port that's always at the low point, no matter the strainer's orientation. We also put ports at the top of the strainer for insertion of a pressure gauge so users can see the differential pressure and tell when it's time for cleaning. Additionally, there is a large port for a dry well and thermometer. This is the best product on the market today, period. So how good is it? To prove that our design is superior, we sent both our strainers and our competitors to the Utah Water Research Laboratory. The Utah lab is considered to be one of the best in the country. Compared to our leading competitor's Y strainer, our strainer produces a fraction of the pressure drop at equal flow, resulting in significantly higher flow coefficient, or C sub V. The numbers were even more impressive when we tested an LPD strainer with a clogged screen. When the LPD screen was 50% clogged, it still had a lower pressure drop and is more efficient than our leading competitor's clean Y strainer. In order to show you exactly how much better our strainer is in dollars and cents, we have a calculator on our website that allows you to enter energy costs, flow rate, and differing amounts of debris. For instance, given energy costs at 12 cents per kilowatt hour, a system running 24/7, and a flow rate of 325 gallons per minute, which is 8 feet per second, the 4-inch LPD Y strainer saves you $224 each year compared to the leading competitor's strainer. And that's before you factor in any potential clogging due to debris. As our test shows, throw some dirt at us and we get even better. I hope you'll look at our competitor's literature, but please note, because the LPD Y strainer screen is so much bigger, equal amounts of debris have far less effect on the flow. So don't look at the competitor's chart with 20% clogged and compare to ours at 20% clogged. For our 4-inch strainer, a clog the area of $1 bill results in $32 of additional energy savings per year. In many cases, the LPD strainer will pay for itself in less than a year. We're now down here in the warehouse where I thought it would be interesting to see some of the other size strainers. And let me repeat something we said earlier. This strainer, 50% clogged, is better than our competitor's clean strainer. And that reminds me, basket strainers. Most people believe they're bigger, lower pressure drop, and therefore don't need to be cleaned as often. Here's a competitor's 6-inch basket strainer, and here is our 6-inch screen. You tell me which one needs to be cleaned more often. We've scienced the heck out of this thing. It is the new industry standard. Please check out our website, and thank you for listening.